So we're going to do explicit first. Explicit, all we need to do is fill in A1 and D, clean it up, and leave it alone. So if I have A1, I have AN equals 39 is A1 plus -2 times n minus 1. Now the cleanup, we have AN equals 39 minus 2n plus 2, because I multiplied -2 by n and -1. Everybody understand that? And the explicit formula is going to be AN equals 41 minus 2n, or -2n plus 41. I'll take either one. So that's explicit. Let's do recursive. The first 6 problems, your recursive problem is going to end up with AN. Okay? Your second 6 is going to start with an AN plus 1. And this is just getting you used to when you get into high-level math in college, they often talk about A sub n plus 1, A sub n minus 1, A sub n, okay? And when they do that, you'll have a little bit of practice because it happens in science and in math a lot. Have you seen this at all in science yet?
No.
All right, AN means the nth term. What does AN plus 1 mean?
N plus 1?
The next term after AN, yeah.
Or minus 1 is the term before that.
Very good. AN minus 1 is the term before it. If you can think of it like that, right? So to get any term, you get, if you're starting with AN, to get any term, you take the AN plus 1 and you subtract the D to get to AN. So AN equals AN plus 1 plus 2. So if we start with AN plus 1, let's say we start here with 37, okay? We have, let's see. So AN plus 1 equals the guy before it plus D. So when you're doing it in terms of AN, which is what they want you to do for 1 through 6, okay? So this is the answer for number 1, actually. When you're doing AN, it's the next guy minus D. When you're starting with AN plus 1, it's the guy before it plus D. You understand that? So this is AN plus 1 equals the guy before it, AN, minus 2. So if I were doing 7 through 12, this is the answer they want. If I'm doing 1 through 6, this is the answer they want. You're defining this formula as a term equals the guy after it minus D for A1 equals 39. So that's where it starts. And here you would write the same thing. So that's part of the answer too.
Why is that part of the answer?
Because you have to tell the guys where to start, because they don't know where the series starts. So how do we use these formulas? Let's say I want to find A5, because I have A1, A2, A3, and A4. Now, you know what is A5?
31.
31. Very good. Well, let's put it to the test. A5, if I'm using this formula, equals A6 plus 2, right?
Yeah.
But I don't have A5 or 6, so I'm going to use this formula. A5 equals A4 minus 2. Now that works because you have an A4. Do you understand that? Which would be A5 would be 33 minus 2, which is 31. So your answer for number 1 is AN equals 41 minus 2N, which I find explicit does a lot more than recursive, but let's just, and AN equals AN minus 1 minus 2. So those are the answers you get. And we have the problem is 39, 37, 35, and 33, right? And here you have to write that A1 equals 39. That's part of the answer. So for number 1, this is your answer. Now let's put it to the test. If I want A3, that equals 41 minus 2 times 3. See if that works. So that equals 35. Oh, that worked. You understand that? Now let's see here. If I want A3, that means n is 3. That would be n is 3, 3 minus 1, minus 2. So A3 would be A2 minus 2. What's A2? 37 minus 2, 35. They both. So to find the explicit, it's an equals a1 plus d times n minus 1. We don't fill in the n's. We leave those alone, but we fill in the a1 and the d. What is a1?
1.
What is d?
200.
Now we clean it up. Everybody should know how to FOIL by now. And now we have 200n minus 199. That's your explicit formula. If I'm trying to find A3, what can I do to A2 to get to A3?
Add 1.
So it would be AN, what do we add?
Plus 200.
Very good. That's it. And A1 equals 1.